Okay, so I'm sitting here in my kitchen, and I'm going to record a video. Got a request from a student last night about extra problem set '02, and she said I did. She said, if I interpret correctly, she said I got everything except the last two problems. So what I'm gonna do is record a video for these last two problems, or two videos for these last two problems. I'll tell you at the outset, I'm sitting in my kitchen with my favorite place, and some of my favorite people are in the kitchen here with me. And so there's gonna be a little bit of background noise, and I'm just not gonna worry about that. So if it's distracting to you, I apologize at the outset, but you know, it is what it is. So anyways, what I've done here is I've taken this problem. I'm gonna do this problem first. I've snapshotted it and I put it over here to my whiteboard. Okay, so you see what I got there? Question number 9, I put over to my whiteboard, and I'm gonna go to my whiteboard and pretend like I'm a student. I'm here in my favorite place, in my kitchen, and I'm relaxed. Got a cup of coffee here, and it's Friday morning, and I'm just going to enjoy my way through this. Okay, so I see here, what is the magnitude of the force? So I know I'm looking for a force between two protons. All right, well, I've looked at this a lot, right? So I know that protons are electricity or electromagnetic or whatever. So this is going to be the force of electromagnetic, which sometimes we say force sub Q. I don't know why we use Q for this. Q is for charges, I think we do sometimes. I'm not sure why. But I know it's the force for electrostatic or electromagnetic force. So I'm going to pretend like I'm a student now. I go over to my PowerPoint. This is the PowerPoint that we have in class. This is available on D2L. And I look up forces, got it. So I scroll through here, and I see, all right, there's forces here. Oh, there it is, electromagnetic force. Problem 1, we did one that was like it, that was gravitational force. I showed you the video on that one already. Electromagnetic force, I'm going to scroll down here and look for, I'm going to read this definition. None of this makes any sense to me. Oh, gravitational, okay. Doesn't make any sense to me at first. Kind of looking at, okay, I recognize that formula. We use that one for problem number 1. Still force of gravity, okay, electromagnetic force. I take a few minutes and read these things. I don't understand any of it, not a big deal. I keep going. I see a formula here. Here's a formula for a force. Here's the formula I'm looking for. There's charge 1. And I know this because I've read this down here, okay? And I'm going kind of fast. There's no way you'll be able to follow me as I'm doing this part. But I find this formula. It's really what I'm telling you. That's how you would find it. You would do what I just now did, except you would take longer because you'd be reading, right? So this is the force I'm looking for. Force is equal to K, Q1, Q2 over R squared. Let me go back to my problem. And, there's a distance right there. Okay, so I got a distance. And I got 2 protons. And here's the charge of the proton. Got it. Okay, so this is going to be K. I'll have to look that up. Q1, Q2 over R squared. All right, so I'll look K up in a second. It's going to be K just setting myself up here, right? Q1 is 1.6 times 10 to the minus 19. Q2 is the same, so it looks like that's just going to be squared, right? Okay, so, and then the R is a pretty short distance, 1.6 times 10 to the minus 6. This is convenient. Look at that. 1.6, 1.6. And this is 1.6 squared. Ooh, look at that. So this is 1.6 squared. And this is 1.6 squared. So I'm going to cross that. I'm just going to cross these off. Wow, that was nice. Okay, so in that case then, this is going to be K, which I'll look up in a second, times 10 to the negative 19 times negative 19, or times the negative, which is negative 38 over, put that in blue, over 1 times 10 to the negative 12, right? And so, and if you don't believe me on that, prove it to yourself. Go on a calculator. Actually, I'll do it right here. 1 times 1 times 10 to the, that's what E stands for, 1 times 10 to the minus 6 squared equals 1 times 10 to the minus 12. You see that? Okay, well, I don't want to do that there. It's hard to read it there, but you saw what it was. Okay, so that's what there's 1 times 10 to the negative 12. We did that, you know, on the first day. We practiced with scientific notation a little bit, but you may need that some more. Now, this is the same thing as, let's go, am I in blue? This is the same thing as K times 10 to the minus 38 times 10 to the positive 12, right? Because I moved this up to the top. This is getting easier now. This is going to be K, I'm keeping my scientific note, or I'm keeping my orders of magnitude in red. This is going to be negative 38, positive 12 times 10 to the minus 26. Okay? And so I'm going to go look up K now. Can't wait, can't delay on that any longer. It might already be here. It might be given to me in the PowerPoint. It is. Look at that. 8.99 times 10 to the 9. And I'll get the units for that in a second, okay? 8.99 times 10 to the 9. So let's put that in blue now. Times 10 to the 9. That's my K, right? So let's bring this now. Times 10 to the negative 26, which is going to be equal to basically 9. I got it. There's my 9 up there. Got it. 9 times 10 to the, and then 9, or it's minus 26 plus 9 is going to be minus 17. And that's what I have. Look at that. Awesome. Okay, and I'm done. Done with that problem. All right. If that's not clear, please let me know. We'll add to it or take away from it or whatever. Make another video. I don't care.